Well, friends, we're in our third video of related rates. This is video C, and we're going to talk about related rates with the Pythagorean theorem. And, you know, the Pythagorean theorem shows up all the darn time, but the key is that I must have a right triangle to deal with it. That means whenever I see something like north, south, east, or west being used in a problem, I'm going to have to think about the Pythagorean theorem. The other case is, you know, buildings or trees. We're going to probably assume that everything comes out of the ground at a right angle. So let's begin. So our problem is a 24-foot ladder is leaning against a building and starts to slide away. The base of the ladder is sliding at 2 feet per second. How fast is the top of the ladder moving when the base is 15 feet from the wall? So that's our problem, and our first step is to identify information that we have, and the base of the ladder is sliding at 2 feet per second, and I'm going to call that dx dt is equal to 2. Once again, that horizontal distance is a function of time. Now, what we're looking for is dy dt, how the vertical part of the ladder is changing. That we don't know, but we want to know this when x is equal to 15. Okay, so that's our first step. We can notice our units, we played our games here, and now let's try to make a picture. And so here's our building, here's the ground, and like I said, we assume right angles. So we have our ladder here, which is 24 feet, and x is getting bigger, yes? dx dt is a positive number. The ladder is sliding away. And what we're going to be looking for here is dy dt, how that height is changing, which means the y must be there. If only I could figure out the way to relate x, y, and 24 on this picture. Oh, and you know that it's the Pythagorean theorem, right? X squared is plus y squared is equal to 24. So once we have the rock, what are we going to do? We are going to take the derivative. Now, keep in mind that x is a function of time, that y is a function of time, and then that ladder 24, that's not a function of time because that 24 is a constant. So let's take the derivative here. We'll have 2x times dx dt plus 2y times dy dt. Perfect. And that's going to be equal to 0. Now, in our next step, I like to solve for the thing that's unknown. So I'm going to solve for dy dt. I'm going to bring it to the other side of the equation, and I'm going to divide by 2y. So dy dt is going to be equal to 2x dx dt divided by negative 2y. And sure, the 2's can murder the 2's, and we can just wrap that up as negative x over y times dx dt. All right, now it's time to plug in and see what we get. So we have our dy dt, that's what we're looking for. And you know, I could say alternately, we could plug these things in first and then solve for dy dt, but you know, 6 of one, half dozen of another, it doesn't really matter. So we go to solve, and we're going to start plugging information. And so x is equal to 15. And the question is, how on God's green earth am I going to get y? And I'm going to make a little picture here. The ladder was at 24, and y is unknown, but x was 15. And you guessed it, I'm going to use the Pythagorean theorem to get that y value. And so we can say that this is equal to the square root of 24 squared minus 15 squared, which turns out to be a glorious square root of 351. Which is approximately what? Approximately 18. But I don't even care. I like exact answers better. The final move is to put in dx dt. And dx dt, and that was the negative right there, was still 2. And so dy dt is equal to negative 30 over root 351. And if I wanted to quantify that, I could. And I would get a glorious negative 1.6 feet per second. Okay, let's see if this makes sense. This was step 6. Finally, step 7. And, you know, if I have the ladder and it's going to have the same side on each, if it's equal, if I have this equal ladder, or this isosceles triangle, as this one gets smaller, that one's going to get, or if this one gets bigger, that one's going to get smaller at the exact same speed. The fact that the x is bigger, it makes sense to me that this is getting bigger and this is getting smaller a little bit slower. Okay, so I think yes. I also like the fact that we got that negative answer, and sure, that height is decreasing.